And let's see. That's the right button here. So this would be 8 sine 82 divided by sine 55. Yeah. Or close the parentheses too. Okay. You should be okay if you did that. Because it's straight. Oh, okay. If you were getting a negative, you might be in radian mode. So make sure that you might have had everything set correctly, but if you were accidentally in radians, you'll get a negative answer sometimes. Were you in radians? There you go. Then you did fine. All right. Gotcha. Then you're fine. Hey guys, this is a super common thing. If you start getting negatives or you get something that just does not look right at all, you're probably in radians. You probably just say something silly with that. What's that? Radian mode. If you don't want to be in radian mode. Whenever we use calculators in here, we're never going to be in radian mode with trig. There will always be in regular mode. You'll use some radian stuff with the calculators in pre-calc, but not here. I stick with degree stuff. Other than that, are we okay on the rest of it? All right, let's add to it. What do you got? What? No. It's fine. Give me a second. I got to find passes. So here's what I want to talk about today. Sometimes you have that. But as you recall, there's no ass in that. That's why I wrote it as the other way. Okay. Now, sometimes, hey guys, sometimes what happens here is that you will be given different scenarios as far as the law of science is concerned. And what I'm saying here with this whole basically, remember, there's no ass in math. So that's what we say. It's a sa. So it was kind of like this. And you guys looked at problems like this yesterday. And you had stuff like that. When you saw that last week, we knew that you were trying to, let's write this out. A problem like that forces you to find an angle first. Which angle are they forcing you to find? B. Trying to force you to find angle B. And the reason that they're forcing you to find angle B is because they have side B there. Now, what's going to happen here today, and this last week we never came across this at all, because most of the values of angles, the angles that were given you, if you go back and notice, I think most of them were already obtuse, and we didn't have to worry. Now, there was a question on the homework that you had one where you had no triangle create. There's kind of like, I think it was 48. No, not 48, 28. 48 was a area problem, I think. Or with something like that. But there was one where you had one that wouldn't work, and the reason why it didn't work is because, let's say it was like this. We know that can't happen, because in a triangle, if you have one obtuse angle, you can't have another obtuse angle. And this being a 140, every other angle has to be smaller than it, which means they couldn't have a side like a 14 unless it was opposite the 140. We talked about that last week. What's going to happen here today is that this angle might not be obtuse, and we have to do a little trick. Because sometimes with the law of sines, you can get what's called the ambiguous case, and you could have two triangles created. And this is a scenario that we never talked about in geometry. I know that for certain. And we usually talk about it just a little bit with what's called the ambiguous case of the law of sines. And there is this huge, long-winded, nasty, awful chart of how to check to see if you do happen to have two triangles. Or you can use my simpler, easier method. And you may ask, how much would one person pay for this? Would you pay 3 easy installments of $39.95? or a one-time fee of $7. I'm just making stuff up. So here's what happens. Let me show you this nice little trick here. I think it was this one. Yeah. Same deal. Let's start with values given. And go from there. So if I'm going to start with angle A being at 70 degrees, little a is 155, and little c at 160. Remember, first thing we're going to do is draw a rough sketch. So we have 70, 155, and 160. You okay with that? What is this forcing you to find first? Angle C, good. So it's forcing us to find angle C first. So we know that if I write it out law of sine, we get the sine of 70 is to 155, as the sine of C is to 160. But cut this light, the glare is pretty bad today. Is that okay? All right. Now, since we have to get C by itself, remember we just have to multiply the 160 over. Oops. And from there, we figure out what that nasty decimal looks like, and then we just take the inverse of it. Okay? So one of two ways of going about it. Let me move this over just a hair so I can see it as I'm writing. I'm going to clear this and make a fraction bar. I have 160 sine 70 over 155, and I get some decimal. You okay with that? What buttons do I press now to figure out the angle of C? Second sign of my answer. You guys get more accustomed using the answer button? Yeah. And I get an angle for angle C of 75.93. You okay with that? If you need to use one because you can see buttons and stuff like that, my calculator's in my bag if you want to grab it. It's in the front. What's that? Oh, yeah, you can use that. Yeah, I think that one isn't. Never mind. So angle C then gets me at 75.93. Now here's the deal. When I'm checking to see if I have a two-triangle scenario, what I do right away is I'm going to figure out what is the supplementary angle to 75.93. What does supplementary mean again? Add up to 180. Good. So what I do here is off to the side, I'm going to take 180 and I'm going to subtract 75.93, which is angle C. Okay? And I'm labeling what I'm doing, that way I remember what that number meant. So I'm going to take 180 and I subtract 75.93. I get 104.07. We okay with that? So the supplement there is going to be 104.07. And what I'm going to do is I'm going to call that C prime as a secondary angle. Okay. Now here's the thing. When we're using this law of science with what we call the ambiguous case, sometimes it is possible to have a secondary triangle. And what we're doing here is we're checking to see if the supplement of angle C leaves us enough degrees with the original given angle to make a second triangle. Because as of right now, we have a triangle that has 70, we have 75, 93, and then we can find out angle B just by subtracting out, correct? Now, what I do here is, by checking its supplement, I'm kind of doing the same thing. What's up? And now I'm going to take that 104.07. I'm going to add that to my original angle given. The original angle given to me was how much? 70. If I do this, off to the side, I always write this, what I'm doing, 70, which is angle A. I'm going to add that, and I get 174.07. Are there enough degrees left to make another triangle? Yeah. So what you're doing here is you're always going to check the supplement of the first angle you're forced to find, add it to the original angle to see if there's enough degrees to make it work. If not, you know there's no two triangles. If so, we just solve two separate problems. Yes, ma'am?
What do you mean by
degrees? Okay, so when we did this one here, we found angle C to be 75.93. When you take this triangle with A, B, and C to start with, I would add 70 to 75.93, and we get what, 145.93, I believe. If I subtract that from 180, we're gonna get 07, 9 to be a 4. I get angle B up here at 34.07. And that's what we would have done normally, correct?
Yeah.
Now, with this idea of what's called the ambiguous case, when we have this side-side angle scenario, by checking this, the 104.07 is the supplement to 75.93. And the reason that this works, this shortcut, is because of something you haven't learned yet. Remember we talked about that whole thing called the unit circle a little bit? We kind of just briefly discussed it. You had a question real quick before I go too far. Not necessarily, and it depends on what the original angle was. I'll show you an example. All right. When you go through, remember we did this earlier, we said that these were both positive here and here. It was negative, positive, negative, negative, positive, negative. Remember that? And then we said this was 0, 90, 180, 270, and then 360. If I have my original angle that we found for C was what, 75.93? Is that right? So 75.93 would be somewhere in the first quadrant. If I come up here, you guys okay with me just labeling it like that? That value has some ordered pair, x and y. The sine of that angle also occurs over here. So sometimes, if you're at the right amount of degrees, this value here and here can be the same. Because remember we talked about what comes first in the alphabet, x and y? What comes first in the alphabet, cosine, sine? The sine of an angle in the first quadrant has a matching sine of an angle in the second quadrant. They're called reference angles. So what happens here is that supplement was allowing us to get how many were left over to get up here, and they shared the same value. So depending upon what the other angle is, you're able to see if it's going to work. It's a horribly complicated way of explaining why it happens than just saying, subtract it from 180 and check to see if you have enough degrees left. Okay? So what happened then is then you'd have two problems. What you would do is, let me split this into two pages real quick. It's easier to see. We have our first one here where we have that 3407 that we got. We have to find a little b here. And then the secondary triangle, we know that we had started with the 70, a 155, a 160, and then we were able to say that the other possible angle was 104.07. And then I could solve for a second triangle of B, second triangle of little b. And this happens because there's certain degrees you started with that you have left over, because it can bounce into the second quadrant. So you go back here, and we have our sine of 70 is to 155 as the sine of 34 .407 is to little b. Sorry about the fives and the sign. I didn't realize it was going to look that bad. If I type that in,
So let's see, 155 sine 3407 divided by sine 70.
I get little b at 92.40. Yes, sir.
So if you change the rule for the second triangle, but why didn't the side line for this one?
Because it was given that way. What happens here is that when you have that side angle, did you guys? I know I didn't do it with my geometry class, but in Seb's class, did you guys do that one computer program where you're given certain side lengths that sometimes you could get that extra triangle?
Yeah.
That's why that was happening. Because it is possible with side angle to create congruent triangles because of the way that things can bounce over. But that angle could have two different side lengths depending upon how many degrees were with the first set. So it's kind of goes hand in hand with what that old computer program that he shows you guys. All right. So then you get the whole triangle here, but then you go back to the other one. So we have 174.07. That gives us what? 593 for B prime. So 5.93, and then I just do another law of sines. No, because the A was the value of A and the side A, those things are always going to be the same. What's happening here is that you can just get the other angles depending upon what's left over to make it work. Mm-hmm. Yep. Yeah. Yes, ma'am. It'll work that way. Because if the supplement doesn't fit, then it won't work. It'll automatically, because here, when I had the smallest angle had the smallest side, that 92.4. The biggest angle was the 75, and it had the longest length. It'll do the same thing over here, because we have the 70 to the 155, the 104 to the 160. When I do this, it'll be short. I think it's like 3. Did you guys get? Like 3 point something, I think? Let me write this out. Oh, 155 times that. I for some reason I thought I got 3 something. Oh, it might be a different problem then. It's not 3, Murphy. I'm sorry. 17.04. So little b prime would be 17.04. So you see how that it still works out that it's biggest to biggest, smallest to smallest. It'll still follow that same pattern. It's a weird scenario. It takes a couple of tries to get used to it, and it happens to work really clean as you get going. Because all you have to do when you first find that angle is just check the supplement. And if it works, great. If not, you have one triangle. Yeah. Yeah, because if you have side angle, that means it's forcing you to find an angle first, and then you would go for it. Okay. If you have two angles, you don't have to worry about it, because then you always have just one triangle. Try another one. On the same page. Try another one like that. Right, it's always missing out on all the fun, right? Again, the very first thing I'm always going to do is draw a quick picture to get a visual representation. That way I know what parts go across from which ones and go from there. Remember, it doesn't have to be accurate. You just have to basically draw a triangle. I know, it's so hard. Oh, my workload is. So 56, 13, and 14. What is this forcing you to find first? Angle A. If that's less, it's forcing you to find angle A first. So by doing that, same deal. We're going to write out a law sine setup. Move this guy over here. I'm going to have the sine of 56 is to 13 as the sine of A is to 14. Is everybody okay with me just making this one quick step then and doing this? Let's bring the 14 over. So I'm going to type that in my calculator. I'm going to get 14 sine 56 divided by 13. And then I take the inverse of that to get the angle. Inverse sine of my answer, and I'm getting 63.23 for angle A. Everybody else get that? Or did I hit the wrong button? Jordan, you got it. I know you did. You're awesome. Sign stuff in your head. Verify. Okay. So now, right away, I'm going to find the supplement. 63. So I take 180, subtract the 63.23. We get, and I'm going to call that A prime. Yes, sir. I see where you're going with that, but you always want to check the supplement because that's kind of the why it works. I know where you're going with that. I think there's a case that it doesn't happen that way though, and that's when it goes back. And I'll show you the whole list of things you'd have to double check. I think it's like 5 things you have to check versus subtracting from 180 to see what's left over. 116 plus 0.77. What do I add to that to check to see if there's enough degrees left? 56. So if I add that to 56, which was angle B to start with, we get what? 77, 2, 7. Are there enough degrees to make a secondary triangle? Yeah. And then you just know that you'll have a second triangle. You already know that angle B is 56. That won't change. You figured out that the original angle C we can get by subtraction. And then the C prime, if you will, we would subtract out again. So let's see here. Our angle A to start with 63.23. The original then, angle A would be, subtract out another 56. That's 60.77 for the first triangle. Okay, that'd be the first triangle. In the secondary triangle, let me dual page this real quick. If I take the 180 and I subtract out the 172.77, it was 7.23, would be angle C prime, and then I have a second triangle. The A doesn't, the B doesn't change, that was already there. Our A prime was 116.77, 56, 14, and this was 7.23. And again, your biggest angle will be across from the largest side length. Yeah. Yeah. Yep. And the reason this happens is it's because what happens sometimes with side-side angle is that given 2 side lengths and 1 angle, there theoretically could be 2 triangles that could be created. And that's why we always say we can't prove triangles are congruent via that, because it doesn't always work. Yes, sir. The A prime, well, you're okay with how we found the first angle A, correct? No, I mean, find the first angle A, we got it from the law signs. And the first angle C, then we got from subtracting out from 180, okay, from that first triangle. The A prime comes from the supplement of what you found at A. A prime will always be the supplement to the first angle that you find to check, that first prime, if you will always be the supplement of the first angle you find. It's kind of weird. It's a lot of words. And then if you do your last bit of sine stuff here, we have to sine that again of 56 is to 13 as the sine of 60.77 is to little c. This one would have been sine of 56 is to 13 as the sine of 7.23 is to little c prime. I'm getting 1.97. And 13.6. Oh, wow. 13.68. And again, the only way to kind of tell whether or not you're close-ish is whether or not your sides match up. Okay, if your sides match up, small to small, large to large, to the sides match the angles. Excuse me. You go from there. All right. You want to take a try on your own? You can do it. I would like you to try. What's up? What do you mean? Oh, if let's say you get the supplement, and let's say this one was like 180 or 177. If you add to 56, then you know that you can't make two triangles. Yes, sir. This is just to double check to make sure you can't make a second triangle. So if you can't make, if it winds up being over 180 degrees, or the angle you find supplement plus the angle that you're given are more than 180, then you only are going to have one triangle. This is just a little quick fail-safe way of checking it. Okay. In other words, I'm just teaching you the shortcut instead of the long cut, if you will. Yeah, you can get no triangle, because then it looked like the problem we did last week, where you had the angle, it was like 140, but it was across from the side that was too short. Okay. What was I going to say? Where is the problem? Oh, no, those aren't your homework problems. Let me see if I can find it. Oh, yeah. So here's this huge, nasty list of things that you have to go through to check to see if you have triangles or two triangles or one triangle or two or none. So yeah, I think the way that I'm showing you guys, just by bouncing the supplement to see if it works, is a lot easier than trying to memorize all that. Because I don't even remember all that. That's just awful. Yeah. What's that? Yeah, sometimes. So angle A is 10, little a, 5, little c, 25. This may or may not be one triangle, two triangles, or no triangles. I don't know. Give it a shot. Okay.
Hi, Devin.
Devin, I totally forgot to email you the sheet. I think I have it online. Is that guy out? I did post it, right? I thought it was. What's that? The email just saying that we're going to test out of this stuff by the end of the week. Yeah, I'll make sure I'll post it right away. I forgot, guys. I'm sorry. I didn't realize I didn't PDF the file. I'll get that done before I go to my class tonight. Yeah, we're going to be done with this unit without too much of a hassle by the end of this week. Tomorrow we're going to do the law of cosines, which again is mainly formulaic work. I won't make you guys memorize law of sines or law of cosines. You just have to know when to use them. Then tomorrow into Wednesday also, I have some a little bit of word problem ones. It's basically, remember when you guys did elevation depression problems, you had to draw pictures? Same idea with law of sines, law of cosines. They're just no longer right triangles. You just have to understand, I went north, I went west, things like that. How do you draw those things out versus degrees and stuff? So it's pretty easy to set them through. Then we'll have a whole bunch of review stuff on Wednesday into Thursday. I don't know if I want to call it a test or a quiz or I don't know. We'll see how we do. Yeah, you should do really. Actually probably do really well. It probably should mark as a test. You know, probably, I don't know. We'll see. I've been trying to figure it out. I'll figure it out how it's going to work. I haven't written it out yet. I kind of know what I want to do, but I don't. Don't worry. And it's all calculator. You kind of have to have a calculator to do a lot of this stuff. So I don't worry about that. Yeah, no. I'll give you a trig table and an abacus. What's an abacus? The county? Not a gnome. Gnomes don't do math. They do math. Actually, I don't know very many gnomes, so. You guys okay with this being just kind of procedural as we go through it? I guess I never realized how many times they put fives in with all this stuff. It's kind of annoying. I was just going to say, speaking of. Then go take his pencil away. Nerd. You and your multi-pencils. Did you guys get 60 1/4 for angle C? Did everybody get that for angle C to start with? Okay. Now, remember your trick. Your trick to see if it's going to work. If I take that 119.75, what do I add to it to check to see if there's enough degrees left? 10. If I add 10 to 119.75, what do you get? You get 129. So is there going to be enough degrees left over for this one? Yes. So then you'll have a secondary triangle. Still a 10, a 5, a 25. What was the question? Oh. So just right there by writing that out, you'll see that you'll have two different angle B's that you can have. One of them is, let's see, maybe subtract the 109.75 for the original. And the other one could be at 50.25. I did. If I take 180.
Put 180.
Yeah, that is the C prime. That is the C prime. What I did here, this was the original angle A, and I was checking to see would there be enough angles left over.
So when you add
That's to check to see if there's enough degrees to get back up to 180. I guess we could write it differently. We can start with the angle C and then rewrite it as 180 minus the C prime minus your original A. Are you positive or negative? Go through that. And then lastly, you have to figure out the two side lengths for B. Finding the side lengths at the last bit there shouldn't be so bad. I mean, even Nelson's bouncing around. She must be happy about this. So as we start again, sine of 10 is to 5. Sine of, what is that, 1? I can't make my own handwriting. 50.25 is to little c, that's little c prime. Just checking to see if you're paying attention. Good job.
I appreciate it.
You're welcome. I forgot. Is that a 107? 109. Thank you. And that would be the, bring that over, so it would be 5 sine. I meant a different triangle. I went back to this one. That's where it becomes possible when you write it out. That's why I always like with primes and stuff like that. But I always reuse the first thing I was given. So 5 sine. It just so happens sometimes you get numbers that are just so darn close in value. 109, 119. And the other one I got 27.1. Please don't fall. Please. I didn't understand a word you just said either. Terrible. So tomorrow when we get law of cosines, depending upon the type of problem, usually you don't have to check the law of sine in this case, but I have to know. I have a handful of these left over for you. If there's room to do it on the sheet, great. This is kind of a mixture. Not all of these have 2 triangles. Maybe one of them, maybe 6 of them, maybe 2 of them. I don't know. Always check law of sine if it's side on angle.
So when you add it,
Welcome. Ladies, welcome. They're off. Yes, ma'am. I don't know, maybe. Maybe I'll just stand into the window later on. Why? All right. Again, just go through these things here. The only time you have to check to see if there is a 2 triangle scenario is if the first triangle is in that side angle, because you got to cover your ass. See what I did there? That was funny. It made sense. You're so polite to me. You're like, in the back of your mind, you're probably like, Murphy, you're such an idiot. But you're always like, you're funny. He walks out of here and she's probably like, how many days of school do I have? Oh, you know the answer to that? Just perfect time. He raises his hand. Murphy, there's 12. No, once you can only get up to 2. You can't have more than that. Hey guys, this is a good question. Guys, this is a good question. There's no possible way to have more than 2 triangles. You can only have up to 2 triangles. You can't have 3 or 7 or anything like that. Yes, sir.
When we find the triangle, do we check for double triangle?
No, nope, you don't have to do that because then those are all side angle signs. Because it wouldn't happen. You wouldn't have to worry about it because they're giving you side angle signs.